Alright, so we're on part 2 of this series where I design a car, and on this section I'm going to be basically building off of the general scaffolding that I built last part. And just to go over the basics of what was accomplished last time, I made a general profile that was representative of the side and the top-down view. And these are the most critical because they're really what's going to define the overall silhouette of the car. And granted, the front and the back matters a little bit less because those profiles are going to be a little bit more obscured by the height of the car and the height of the windshield on top of that. And from the rear, it's going to also be obstructed a little bit by the canvas top that's going to be either up or down in the roof line. And you can't really change that or alter that in any major significant way. But regardless, what I'm going to start with first is, as you can see, I'm just tracing the overarch of the wheel, or the wheel well. And what that's going to do is just provide a general baseline of where everything's going to be referred to, and more specifically what I'm doing right now is I'm just going to attach those 3D curves to where I want them to be on a two-dimensional plane based off of that scaffolding that I just mentioned. And then what I'm going to do is I'm going to free these points, and I'm just going to shift them over wherever they need to be, referencing the top plane, which I'll switch to later, yeah, right around now. So as you can see, I'm just sliding them roughly over to where they should be, and only on that one axis, drawing them away from the center line of the car. And this is important to make sure that it's easier to see it from this profile. From the right side view, it still looks like the control points are more or less where they were before the control points were freed. So that's really the main reason why you set up the scaffolding beforehand and set up everything, do all the due diligence and the busy work. Really is what it feels like, but it's very important. It saves you so much time down the line, and as you can see from the top-down view, as I'm looking at now, it also makes sure that your body lines are consistent the entire way. So this isn't just an engineering challenge, this is also somewhat of an art project as well. And the art is... this is where it stops being engineering and it becomes a little bit more of, as I said, an art project. Because some of these parameters that you're messing with are a little bit harder to quantify. And this includes the exact dimension, or the exact positioning and orientation of the guide curves. It includes the exact positioning of the control points, and it also is the behavior of the 3D curves as they go over control surfaces. This is something that I'll get to later down the line, but it's a little bit more something that you start to see towards transition points. So when you go from the top to the side of the car, and in other words, referring back to the first part of this series, what is the behavior of, let's say, the rear fender as it goes from right over the wheel well to now you're on the shoulder? Does it just sharply turn? Does it more gradually curve like a more classic car? These are choices that you have to make ahead of time, but it's also something you can alter and sort of toy with the look of as you get later down the road. And these choices very critically control the identity of the car when it reaches its final form. Like as you can see now I'm starting to tweak the behavior of the tail end of the car, how it slopes down at the very back. And I think at this point I stepped away to go to the bathroom or something. So yeah, there we go, now I'm back. And this is also something you have to kind of step away from every now and then, as I said, just kind of do your own thing, because this isn't an engineering thing. This is a somewhat non-quantifiable thing that you're doing. And what you're trying to do is sort of, this isn't very good or very scientific terminology, but you're almost trying to orchestrate all of these control points to make them do what you want them to do. You're not really controlling them, though, in a conventional sense of the word. You're more, gonna reference Uncle Iroh here, you're more of a humble guide to nudge them in the direction you want them to go. And ultimately, what you'll end up with is a shape that is negotiated into the shape that you want it to be at the very end. This is how I make larger cars. This is how I make smaller consumer electronic products, like ergonomic hand grips. And yeah, it can be tedious, but this is what it takes. So anyways, the first body line is done. Now what I'm doing is I'm jumping a little bit ahead, granted, here, in contouring the back end, and I think later down the line I actually walk back on starting on this section of the car, and instead I focus a little more on the front. But this is very much where you start to sculpt it into the final shape that you want it to be. And this, I'm saying this a little bit early on a surface level, because this kind of thing does happen relatively early on. All of these control points don't just get drowned under future features. Everything builds on top of itself, so as such it's very common for you to just keep going back, just nudge things in a different direction, and as I said, just negotiate with it, kind of dance around some of the points, see what the behavior is. If okay, what if I slightly increase the tangency in this point? How does it affect these 7 other curves that are also parameterized to the same thing down the road? And what's going on here, just getting back to the video at hand, is I'm actually having a little bit of a processing brain fart, because this is not really what you're supposed to do when you're making wheel wells. When you're making wheel wells, what you want to do is you actually want to more so make a sketch on an offset plane, because wheel wells aren't something that really are 3D features. They're 2D features that are extruded in the axial direction, or the beam direction of the car. So this is realistically the wrong way to do it, and I'm almost glad that I did mess up in this way, because I'll actually go back to this later and fix it in time and do it the right way, with reference planes and all of that. But let's just say you do want to do it like this. You want to do it with 3D curves, and you want to really try and control the exact behavior of the wheel well, which granted is going to have to happen with this particular case, because this is a this is a wheel well that will wrap around the rear wheel, kind of like the Jaguar D-Type, if I'm not mistaken. I believe it had this feature. There's a fly near my face. So for the rear wheel, this isn't something that is against design philosophy, if you will. But back to what I was getting at originally. I got the fly. Back to what I was referring to originally. If you really wanted to make a wheel well with guide curves, what you will have to do is have a very controlled arc with fairly rudimentary tangencies, and you have to position them very specifically. Like, if I'm not mistaken, it would have to be something along the lines of like a tangency with a norm of 1.27, if I'm not mistaken, and then you have to position them as such as that they're perfectly radial about the epicenter of the wheel that is contained in the wheel well. And granted, this does give you some advantages. It does allow you to control more accurately the behavior on a more nanoscale level of that wheel well. But you could also do a very similar thing just by, as I said earlier, just taking a standard shape with a sketch that's offset with a plane and making another extrusion and then splitting it with that extrude cut. And that's, granted, a bit of a caveman-y way of going about it, and it won't give you as specific control over what the final product will be, but it will work, and it is generally a little bit less hassle. And also, generally speaking, most cars don't have a lot going on with their wheel design. So anyways, moving on. What I'm working on now is the side fender, and wait, no, this isn't the side fender, it's the side skirts. And what I'm trying to do here, as I mentioned earlier, is I'm trying to separate the top and the bottom halves of the chassis, kind of like how it is on the Maserati MC20, and or is that what I'm doing now? I am recording this after I have already done this, of course, so I am only recalling this. Okay, I see. So what I'm doing here is I'm doing the same thing as before, same mess up. Okay, now I'm doing it. So here I'm making the offset curve. I'm putting it to one of the control points on the scaffolding that I mentioned earlier, and from here, now I'm making the sketch. And it doesn't have to be a full closed perimeter, but what it does have to be is it has to be consistent with the drawing underneath, and it has to be representative of the space that the wheel will need to take up in the wheel well. But other than that, there aren't any other real hard rules. Like, I think I gave each wheel about 300, 400 millimeters of clearance, which is a pretty beefy tire. Like, I think on performance vehicles you can have tires that have a width of 335 millimeters, and that's considered a really large tire. This can take something up to 375, which I don't know if that's really a thing outside of drag racers, but you can do it on this car. On the front, though, it's you would probably be a little more constrained, probably something closer to the 300 mark, but I wanted to give as much real estate room as possible, so you're never going to be pressed for space on the interior. But anyways, back to the side skirts. What I'm trying to do is just separate the top and the bottom, and I'm also trying to separate it as far as the beam width of the car itself. So the bottom, or the top of the skirt, is not the bottom of the top clamshell, and they are offset by a little bit. And what this allows me to do is it allows me to put some small, very discrete aerodynamic features, such as a I don't remember what the proper term is called, but it's effectively a hole on the back of the wheel, or it's a hole in the fender immediately behind the wheel. And in this case, that hole would be completely covered by the side skirt, which will also provide the normal benefits of a side skirt. On the rear, I'm not really sure where I'm going to let that air go. My initial thoughts are I want it to be a sort of a duct for the brake radiators, but I'm not entirely sure about that yet. That's a mechanical issue that's outside the scope of this video and the initial parts of this here, which eventually we'll get into the more nitty-gritty of the suspension, the fluids, Eventually the engines as well, but that's something I'm not sure if I want to go into, because that is actually the premise for a future company. But I digress. So we have our wheel wells now, and I'm still tweaking the wheel dimensions here. I really should fix the saturation values on these videos, probably make them a little more watchable. And granted, these are also videos that are somewhat outdated. I did fix the issue with the saturation. It was actually something I'm kind of ashamed that I didn't figure out beforehand, but I digress. Okay, so what I'm doing here is just a little bit more playing with the shapes, if you will, and I'm now going into the more nitty-gritty geometry with regards to the wheel arch that goes over the back end of the car. This is going to be a little bit more complicated because it's not, again, this is not going to be a conventional wheel arch, and it's going to be more similar to a wide body kit than anything else I've really done before. So this isn't really meant to be a performance feature, is another way of saying what I'm trying to get at. This is more of a cosmetic feature. But what this will give the illusion of is a lower chassis overall in the rear, and generally wider hips in the back as well. The challenge with this, though, is you're no longer dealing with well-defined shapes. You're more kind of free-handing, if you will. And you also have to keep in consideration, okay, the fender now goes over the tire. How are we going to get the wheel out now? And I believe the drafted solution that I have in my notes is the entire fender will just come off, and it's going to be on a hinge or a 4-bar mechanism of some kind. That's not entirely something that I have finalized yet because it's not really been the priority, but I know that the final solution will look like something like that. But moving on. Now what I'm trying to do is I'm trying to, if you will, fix the geometry that is automatically generated by the program. And this is where a more patient hand becomes needed to operate generative shape design in CATIA, because CATIA will fight you when it comes to large, complex, and very specifically defined shapes, sort of like this, where it kind of bulges out towards the inside. And there are a couple of ways of fixing this. You can change the continuity, so it defaults to, or no, is it continuity? I think it's continuity. It defaults to tangency continuity. Sometimes if you switch it to point continuity, it'll fix this problem, but granted that will have its own issues that you'll have to fight with. You could also increase the I believe it's called the displacement, or the yeah, for some reason the term's leaving my mind, but it's the degree to which a fill feature can go beyond the bounds of, or can deviate. It's called deviation. That's what it's called. So by increasing the deviation of a fill feature, sometimes that fixes whatever malfunction that's causing it to really freak out and create these really weird blobby shapes that go all over the place. The last sort of nuclear option, if you will, is to go back and create a 3D curve that, or no, let me rephrase that. The nuclear option is what I call creating a pass-through 3D curve. And to create a pass-through 3D curve, this is actually something I'm going to do for this car later down the line. The way you do that is you just say, okay, fine, put the fill wherever it's going to be, and then constrain a 3D curve to the border of that fill. And when you do that, it's going to sort of make a 3D curve in midair. And if you, let's just say, delete that fill, that 3D curve will still be there. And what this allows you to do is you can do one of two things. You can either, as I said, delete the fill, or B, you can just move it back in your build tree so that the instance of the 3D curve is now before the fill. And the trick here is what you're trying to do is you're trying to use one of the points of the 3D fill as a passing point. And a passing point is, in effect, just a feature that the 3D fill has to pass through at some point in its propagation or its being solved. And this is a relatively recent tool that I discovered because it has a lot of power and gives you a lot of influence over what the final curve or what the final fill will end up looking like. And it allows you to control relatively unruly models in ways that you wouldn't be able to otherwise in a clean fashion. And also in a relatively smooth fashion that preserves the overall layering, tangency preservation of the other curves that you also have things parameterized around it. I think I make one for one of these frontal fenders, actually. I'm not sure when exactly. It may or may not be in this part. It might be in the next part, but what I'm doing right now as well is I'm trying to sort of keep consistency with the design language of the front end, because what I'm trying to do with the front end is I'm trying to make it so that the outer border, if you will, with the top-down profile of the front end is consistent with the lower edge of the headlights. So the lower edge of the headlights will be the border, if you will, or it'll be slightly withdrawn from the border, as you can see in the top right sketch profile. And this is, again, really stops being an engineering problem, and it really becomes more of an art project than anything else, because what you're doing is you are sculpting. This is very much sort of freehand, using your drawing as a reference kind of artistic expression, because what you're really trying to do is you're trying to just make it look the way you want it to, of course with respect to practical concerns. But anyways, I think it's about all the commentary I'm going to give for the time being. I'm not going to talk your ear off the entire time, so I think I'll just let the rest of this part play out, and please enjoy. Talk to you next part.